Okay, find the area between the two curves. One is the natural log of x, the other one is the natural log of x quantity squared. First thing I do is graph it out. Whoops, sorry about that. I would graph it out, and let me do that. I did it again, sorry. Graph it out. The natural log looks like this. That's y equals the natural log of x. And then if you square that, well, I guess it would sort of look like this over here. I would agree there. And this will come whipping back up and intersect somewhere over here. So I'm pretty clear about this point of intersection. And that point of intersection would occur when the natural log is equal to 0, and that would occur at 1. This one a little more complicated. Let's write it down. It's when the natural log of x is equal to the natural log of x squared. Let's solve that for 0. You get the natural log of x squared minus the natural log of x. I'd factor out a natural log, and you get natural log of x minus 1. And at zero product rule, you'd say the natural log of x equals 0. That, of course, equals 0 when x is equal to 1. And then the natural log of x equals 1, and that would occur when x is equal to e. So I know this point of intersection over here. It's going to be e, comma, 1. This is the area they're talking about. Setting up the interval is fairly easy. It's going to start at 1. I'm moving along the x's. It'll move up to e. The upper curve is the natural log of x. The lower curve is that square problem, the natural log of x squared dx. All right, that's your first goalpost, and that's right over here. All right, we go from 1 to e, natural log of x minus the natural log squared dx. Now what I'm going to do is a u substitution to get to my second goal. U substitution, I'll let u equal the natural log of x. That means, let's take a look at that. That means e to the u would equal x. Let's take a look. So du, let's see, that would be e to the u du would be dx. All right, let's make our substitution. This integration here is going to be equal to, well, when x is 1, u is going to be 0. And when x is e, u would equal 1. The natural log of x is u, minus the natural log of x quantity squared is u squared. And then dx is equal to eu du. All right, this is our second goal. Do I see that written here? Right over here. Whoops, sorry about that. I see that right over here. All right, your path may diverge here. What I would probably do here is split into 2 integrations. So let me just erase some prior work over here. I'm kind of done with all this stuff over here. And I want to work on this integration now. I'm not going to go back to x's. I'm going to stay in the land of u's. And I'm going to split into 2 integrations. The integrations will be as follows. From 0 to 1, u, eu, du. That's one integration I want to do. And let's see if you did integration by parts. Well, let's see what you do over there. It doesn't look like a bad integration. Yeah, I'm going to say, let me do this one first, though. I'm just going to write down a little differently. And what do you get over there? You get, let's see, u would equal x, du would equal dx, e to the x dx would equal dv, and v would equal e to the x. Well, fairly simple. What are you going to get over there? You know what? I'm going to erase the limits of integration just to tighten this up a little bit. And again, this I'm going back to land of x's there, but I'm back in the u's now. And what are you going to get over there? Let's take a look at that. You're going to get u, eu, minus e to the u du. Well, that's pretty simple. You're just going to get e to the u. This is going to get the limit integration up from 0 to 1. I think I can do that. And let's write that down. You're going to get e to the first power minus e to the first power minus 0 minus 1. Well, this is pretty simple, just 1. All right, that just turned out to be 1. All right, let's see if we met that milestone. The first integration. We got the proper antiderivative, u, e to the u, minus e to the u, 0 to 1, and the evaluates to 1. I feel pretty good about that. All right, so what I'm going to do now is the other one, a little more difficult. And the other one is going to be, let's put this down. It's going to be u squared e to the u du. All right, let me get my eraser out. And just doing that second integration now. I'll erase this over here. Again, you know, I hate to say this, I always rely on, you know, what I know best is, you know, writing everything in terms of x's. And I'm going to do that. I'm going to back up here and erase all this business up here. And there's some more difficult integration for me to do. Still integration by parts, by the way. And I'm just going to go back to what I know best, x's. It's a crutch though, isn't it? So what do you have here? X squared e to the x. I would say u is equal to x squared du is equal to 2x dx. I would say, whoops, sorry about that, dx. I would say e to the x dx equals dv, and that means v equals e to the x. What do you get over here? Well, you get x squared e to the x, and then you get minus, let's see what you get there. You would get 2x, 2 on the outside, e to the x dx. Well, we just did that, didn't we? So what do you get? X squared e to the x minus 2. Let's be careful now. Again, we just did that. What's that going to be? X e to the x minus e to the x. Well, I think I can write this down now. 0 to 1. And you're going to get x squared. Whoops, I'm not paying attention. It's going to be u squared e to the u minus 2u e to the u plus 2 e to the u. I'm going to evaluate that from 0 to 1. Well, if you put 1 down, what do you get? You're going to get e minus 2e plus 2e. Well, that's not so bad. That's the upper limit. Let's do the lower limit. Minus 0. What are you going to get? You're going to get 2. So this thing over here evaluates 2. Let's take a look. E minus 2. All right? So let's take a look, see how we did. And certainly I'm seeing if I've met the milestone of being able to get the antiderivative. I think I did okay there, did okay there, did okay there, 0 to 1, and I got the e minus 2. Now what do you got to do? Evaluate the integration. And it's going to be that first integral, which was 1, minus the second evaluation, which was e minus, whoops, e minus 2, which will turn out to be 3 minus e. Final answer. That's right over here. Thank you.